Hey student, how are you? Welcome to our session on using reference angles to find cosine and sine of different angles on the unit circle. Number 1, cosine and sine of 120 degrees. We're going to start by drawing our angle. Here's 0 degrees and going counterclockwise around the circle for positive angles. Here's 90 degrees, 180 degrees, 270 degrees, and then back up to 360 degrees. So it looks like our angle, 120 degrees, will be in the second quadrant, 120 degrees. Now, let's find our reference angle. Our reference angle is going to be in between the x-axis and the terminal side of our angle. And this reference angle we can find by subtracting 180 minus 120 degrees. We get a 60-degree reference angle. Let's find cosine of 60 degrees. Adjacent over hypotenuse. And we can use our reference triangle. Here is 60 degrees. 2 is our hypotenuse. 1 is the adjacent side of 60 degrees, and this will be the opposite side of 60 degrees. So cosine of 60 degrees, adjacent over hypotenuse, 1/2. And then sine of 60 degrees, opposite over hypotenuse. And opposite side of 60 degrees is the square root of 3 over the hypotenuse 2. Now, we are in quadrant number 2. We had to go left to get to quadrant number 2. Left and then up. Cosine is the x value, left and right. So since we had to go left, cosine is going to be negative in quadrant number 2. Sine will be positive in quadrant number 2. So cosine of 120 degrees is equal to cosine of 60 degrees, but in quadrant number 2, so it will be negative 1/2. Negative 1/2. And then sine of 120 degrees will be equal to sine of 60 degrees, square root 3 over 2. Square root 3 over 2. And those are the coordinates, cosine comma sine, x comma y, of this point on the unit circle. Negative 1/2 comma square root 3 over 2, x comma y, the coordinates of this point, 120 degrees. All right, number 2. Number 2. Cosine and sine of 225 degrees. So we'll start by drawing our angle, 225 degrees. That's going to put us in quadrant number 3. This is 180 degrees. This is 270. So here is our angle, quadrant number 3, 225 degrees. Quadrant number 3. And now we'll find our reference angle. Reference angle is in between the x-axis and the terminal side of our angle. To find this reference angle, we'll subtract 225 minus 180 degrees, and we get a 45-degree reference angle. So we're using our 45, 45, 90 special right triangle. Let's find cosine of 45 degrees. Adjacent over hypotenuse, we get 1 over square root of 2. And we can rationalize, we'll get square root 2 over 2. And sine of 45 degrees is the same, square root 2 over 2. Now, since we are in quadrant 3, both cosine and sine are negative. We had to go to the left and down, 2 negative directions, to the left and down, to get to this point on the unit circle. So cosine will be negative square root 2 over 2, and sine will be the same, negative square root 2 over 2, sine of 225 degrees. Number 3. Number 3, we've got 330 degree angle. And we'll graph that. That's going to put us in the 4th quadrant. Here's 270 degrees. This is 360 degrees. So 330 degrees in the 4th quadrant. And now we'll find the reference angle in between the x-axis and the terminal side of our angle. And we'll subtract 360 minus 330, and we get a 30-degree reference angle. So we're using our 30, 60, 90 special right triangle, 30 degrees. Here's our hypotenuse, and this is the adjacent side, and this is the opposite side. Let's go ahead and find cosine and sine of 30 degrees. So cosine of 30 degrees, adjacent over hypotenuse, square root 3 over 2. And sine of 30 degrees, opposite over hypotenuse, 1 over 2. Now we are in quadrant number 4. Quadrant number 4, cosine will be positive. We went to the right. And sine will be negative since we had to go down to get to quadrant number 4. So cosine of 330 degrees will be positive square root 3 over 2. And sine of 330 degrees will be negative 1/2. Number 4, let's do some radian angles. Angles and radians. All right, cosine and sine of 3 pi over 4. Well, let's start by drawing our angle. Here's 0 radians. This is 1/2 pi radians, 1 pi radian. So it looks like 3/4 pi radians will put us in the 2nd quadrant. 3 pi over 4 radians, quadrant number 2. And then we will find our reference angle in between the x-axis and the terminal side of our angle. And we'll find this by subtracting pi minus 3/4 pi. And we're left with pi over 4 as our reference angle. It's our reference angle. So we're using our 45, 45, 90, or pi over 4 special right triangle. And we'll find cosine of pi over 4 adjacent over hypotenuse using our special right triangle, adjacent, hypotenuse, opposite. And we get 1 over the square root of 2, which rationalizes to square root 2 over 2. And sine of pi over 4 will be the same, square root 2 over 2. Now we are in quadrant number 2, so both sine and cosine, just cosine, we went to the left. Cosine will be negative. Went to the left to get to quadrant number 2 and then up. All right, so cosine will be negative square root 2 over 2. Sine will be positive square root 2 over 2. And the last one, number 5, we'll do one more in radians. There we are, taking a look. Cosine of 7 pi over 6. Sine and cosine, 7 pi over 6. Well, this is 1 pi, and this is 3 pi over 2, 1.5 pi. So it looks like 7 pi over 6 will put us in quadrant number 3. 7 pi over 6 radians. Quadrant number 3. And we'll find our reference angle in between the x-axis and the terminal side of our angle. We'll find this reference angle by subtracting pi minus, other way around, 7 pi over 6 minus 1 pi. We're left with 1/6 pi, or pi over 6. Pi over 6 will be our reference angle. There it is, pi over 6, or 30 degrees. So this is our adjacent side, opposite side, and hypotenuse. And we'll use this reference angle to find cosine of pi over 6, adjacent over hypotenuse, square root 3 over 2, and sine of pi over 6, or sine of 30 degrees, pi over 6 radians. We get 1/2 opposite over hypotenuse. And now quadrant number 3, both cosine and sine are negative. So we get negative square root 3 over 2 and negative 1/2. And that concludes our session on using reference angles. Thanks so much for joining our session, and I'll see you next time.